Imagine you are standing on a mountaintop on a clear night. You look up at the stars and you feel small. But there is one star that shines brighter than almost any other in the sky. Ancient people called it the evening star. They named it after their goddess of love and beauty, Venus. Now, forget that name. Forget everything you thought you knew. Because the real Venus is not a goddess. It is a monster. It is a place where the air is poison, where the ground is hot enough to melt metal, and where the sky rains acid. It is the most hostile planet in our solar system. And yet, in the middle of the Cold War, a nation decided to go there. Not with humans, of course. Humans would die in less than a second. But with machines, with courage, with stubborn, glorious Soviet stubbornness. This is the story of the Venera missions, a story of explosions, silence, and one of the greatest victories no one talks about. The year is 1957. The Soviet Union has just launched Sputnik, a small metal ball with a radio transmitter into orbit around Earth. America is shocked, humiliated. The space race has begun. For the next decade, the two superpowers will fight for the high ground of space. They will compete to send the first satellite, the first animal, the first man, the first everything. But here's the question that haunted Soviet scientists. After the moon, where? America looked at Mars, a cold, dusty desert. Maybe, just maybe, life could exist there. But the Soviets looked at Venus, and they had a very practical reason. Venus is closer to Earth than Mars, much closer. At its nearest, Venus is only 38 million kilometers away. Mars is almost twice that distance. In the brutal mathematics of rocketry, closer meant easier. Shorter travel time, less fuel, a better chance of winning. But there was another reason, a secret reason. In the early 1960s, no one knew what lay beneath the thick clouds of Venus. Some scientists dreamed of a jungle world, a prehistoric swamp like Earth's Carboniferous period. They imagined dinosaurs, strange plants, maybe even oceans. The American writer Arthur C. Clarke imagined a planet-wide ocean. The Soviet astronomer Carl Sagan, yes, the same Carl Sagan who later became famous in America, he had a darker theory. He believed Venus was a runaway greenhouse effect, an oven, a living hell. No one knew for sure, and that uncertainty was a trap. Because the Soviet Union, desperate for another space first, decided to find out the hard way. The first Venera missions were not called Venera at first. They had secret names, lost in the fog of Soviet secrecy. But we know what happened. In February 1961, the Soviet Union tried to launch a probe to Venus. The rocket never left Earth's gravity. It burned up or crashed. We don't even know its real name. Historians call it Tyazyeli Sputnik, heavy satellite, a failure disguised as a success. Then came Venera 1, a beautiful machine, if you can call it that. It weighed over 600 kilograms. It had solar panels, a heat shield, scientific instruments. On February 12, 1961, it launched successfully. For 7 days, it sent back data, temperature readings, radiation measurements. Then, on February 19th, when it was 1.5 million kilometers from Earth, silence. No explosion, no crash, just nothing. The probe kept flying toward Venus, but its voice was dead. A ghost ship sailing through the dark. Failure. Another failure. But the Soviet Union did not stop. They could not stop. Because America was also trying. In 1962, NASA's Mariner 2 flew past Venus. It was an American success. It measured the planet's temperature and found heat. Terrible, unimaginable heat. 425 degrees Celsius on the surface. Hot enough to melt solder. Hot enough to kill any hope of a jungle world. But the Soviets did not have a flyby. They wanted more. They wanted to land. Think about that for a moment. Landing on Venus is not like landing on the moon. The moon has no atmosphere. You can use rockets to slow down gently. But Venus has a thick, crushing blanket of carbon dioxide. If you try to land, the atmosphere will grab your spacecraft and tear it apart. It will heat the outside to thousands of degrees. It will squeeze the probe like a fist crushing an egg. And even if you survive that, the pressure at the surface is 90 times Earth's. That is like being 1 kilometer deep in the ocean. The engineers at the Soviet Design Bureau, led by the brilliant and stubborn Georgy Babakin, knew this. They knew the odds. They built heat shields. They built parachutes made of special fabric that wouldn't melt. They built pressure vessels, thick titanium spheres to protect the delicate instruments inside. And then, between 1962 and 1965, they launched again, and again, and again. Venera 2, launched November 1965. It flew past Venus, but its systems failed just before the close approach. Silence. Venera 3, launched the same week. It crashed into Venus on March 1, 1966, the first human-made object to touch another planet. But it was dead on arrival. Its data transmitter failed long before impact. It hit the surface at hundreds of kilometers per hour, a metal tombstone on an alien world. Venera 4, this one almost worked. April 1967, it deployed a parachute in the Venusian atmosphere. It sent back data for 93 minutes. It measured the temperature, the pressure, the composition of the air. And then, at 25 kilometers above the surface, the pressure crushed it like a tin can. It never reached the ground. But it proved one terrible truth. Venus was even worse than anyone imagined. By now, the engineers were desperate. They had lost probe after probe. They had watched their dreams burn, crash, or fall silent. The Americans were flying past Venus with ease. The Soviets were failing publicly. The world was watching. The Politburo, the leadership of the Soviet Union, demanded results. But here's the thing about failure. Sometimes it teaches you more than success ever could. Each lost Venera sent back a piece of the puzzle. Venera 4 showed that the atmosphere was almost pure carbon dioxide. Venera 5 and 6, launched in 1969, confirmed that the pressure at the surface was enormous. By 1970, the engineers had redesigned everything. Thicker titanium, better heat shields, stronger parachutes. They had built a machine that might, just might, survive the descent. They called it Venera 7. And this time, they did something different. They removed almost everything that was not essential. No complex cameras, no fancy experiments, just a pressure vessel, a thermometer, and a radio transmitter. And they hardened that vessel to withstand 180 atmospheres of pressure. Twice what they expected, just to be sure. On August 17, 1970, Venera 7 launched from the Baikonur Cosmodrome. It was a cold, clear morning. The rocket rose on a pillar of fire, climbing through the thin blue sky, then the black, and then silence. 4 months of travel through the void. The engineers waited. They calculated. They prayed, even the atheists among them. On December 15, 1970, the probe reached Venus. The descent module separated from the mothership. It plunged into the clouds. For 35 minutes, the probe fell. The heat shield blazed. The parachute deployed. The temperature outside rose to 475 degrees Celsius. The pressure climbed past 50, then 70, then 90 atmospheres. The little titanium sphere, no bigger than a beach ball, trembled and groaned. Inside, the instruments held. At 5:34 a.m. Moscow time, Venera 7 touched the surface of Venus. And then, nothing. The radio went silent. The engineers stared at their screens. No signal, no beep, nothing. 1 minute passed. 2 minutes. 5 minutes. They had failed again. Or so they thought.
Mission Control Moscow, December 15th, 1970. A room full of tired men in brown suits, their faces gray from lack of sleep and too many cigarettes. They have just watched their probe, Venera 7, fall silent after landing on Venus. For 5 agonizing minutes, there is nothing, just static, just the hiss of empty space. Some of the engineers begin to pack up their notes. Others just stare at the floor. Another failure, another dream crushed by the weight of Venus. But then, a junior technician, barely 22 years old, points at his screen. "Comrade," he says, his voice shaking, "look!" There is a signal. Weak, broken, like a distant radio station in a storm, but it is there. A faint, wavering beep. Not data, exactly, just a carrier wave. Proof that the little titanium sphere is still alive, still fighting. What happened? The engineers would later piece it together. Venera 7 had landed, but it had landed on its side. Its antenna was not pointing directly at Earth. The signal was weak, almost useless. But for 23 minutes, that tiny beacon transmitted. And when the scientists analyzed the faint carrier wave, they found something incredible hidden in its frequency. A measurement. A single, priceless measurement. The temperature on the surface of Venus was 475 degrees Celsius, plus or minus 20 degrees. The pressure was 90 atmospheres. And the little probe that should have died had survived. For the first time in human history, a machine built by human hands had landed softly on another planet and sent back a whisper from its surface. Think about that. Not a flyby, not a crash, a landing. A soft, controlled, miraculous landing on the most hostile world in the solar system. The Americans had not done this. No one had. The Soviet Union, the nation that had been mocked for its failures, had just achieved something no one thought possible. But here's the truth they did not tell the world right away. Venera 7 was not supposed to land on its side. It was not supposed to send only a carrier wave. It was a partial success, at best. The engineers were happy, but they were not satisfied. They wanted more. They wanted images. They wanted to see the surface of Venus with their own eyes. And to do that, they would have to build something even stronger, even tougher, even more insane. The engineers at the Lavachenkin Design Bureau went back to work. They studied every piece of data from Venera 7. They calculated the exact forces of the descent. They tested new materials, new parachute systems. They built a new probe, Venera 8, and launched it in March 1972. It landed successfully. It sent back data for 50 minutes. It measured the light level on the surface, proving that Venus was not completely dark. But still, no images. The cameras were too fragile. The heat would destroy them. So they tried again and again. Each mission taught them something new. Venera 9 and Venera 10, launched in 1975, were different. They were heavier, more complex. They had something no Soviet probe had carried before. A pair of cameras protected inside pressurized containers with special lenses that could survive the acidic atmosphere. On October 22, 1975, Venera 9 separated into two parts, an orbiter and a lander. The orbiter would circle Venus, taking pictures from above. The lander would descend into hell. The engineers held their breath. The lander fell through the clouds. The heat shield worked. The parachute deployed. Then, at an altitude of 50 kilometers, the parachute released, and the probe fell freely for the last part of the descent. This was intentional. A parachute would take too long. The probe needed to reach the surface quickly before the heat destroyed it. It landed. Hard. The shock absorbers compressed. The systems checked themselves. And then, the cameras began to work. For the first time in history, a human-made machine looked out at the surface of another planet and saw not nothing, but something strange, something unexpected. The images were not in color. They were black and white, transmitted line by line like an old fax machine. And what they showed was a landscape of sharp, flat rocks, dark soil, and a sky that was not blue, not black, but a strange, oppressive orange. The probe lasted only 53 minutes. Then the heat and pressure killed it. But in those 53 minutes, it sent back the first photographs ever taken from the surface of another world. Not Mars, not the moon, Venus, the planet of hell. Now imagine being one of those Soviet engineers. You have spent 15 years of your life building machines that explode, that fall silent, that crash. Your friends in the West laugh at your failures. Your own government threatens to shut down your program. And then, one day, you see an image of a place no human will ever stand. You see the rocks, the soil, the sky of a world so alien that it breaks your mind. And you realize you are the first person in 5 billion years of planetary history to witness this. That was the triumph of Venera 9, but the best was yet to come. Venera 10 landed 3 days later. It sent back more images, sharper this time, more detailed. The scientists studied the rocks, the terrain, the evidence of volcanic activity. Venus, they learned, was not a dead world. It was alive, geologically alive, covered with volcanoes, lava flows, and strange pancake-shaped domes of hardened rock. But the cameras had a problem. The lenses were made of quartz, which could survive the heat, but the light on Venus was strange. The thick clouds scattered the sunlight, creating a flat, shadowless glow. Everything looked like it was under a gray-orange fog. The engineers wanted color. They wanted to see Venus the way a human eye would see it. That would take 4 more years, and it would take a probe called Venera 13. By 1981, the Soviet Union had launched 13 Venera missions. Some it failed, some it succeeded, but the program was getting old. The engineers were tired, the politicians were losing interest. The space race was over. America had landed on the moon. The Soviets had built space stations. Venus seemed like old news, a relic of a bygone era. But the Soviet engineers did not care. They knew what they had done. They had conquered a planet that tried to kill them at every step. They had turned failure into victory again and again, and they were not finished. Yet. One more mission remained. One final, desperate attempt to push the limits of what was possible. They called it Venera 14, and it would teach them something they never expected to learn.
By 1983, the Soviet Union had done what no nation on Earth had ever done. They had landed on Venus. They had taken photographs. They had recorded sound. They had drilled into the surface and analyzed the chemistry of another world. They had turned a planet of hell into a place of human triumph. But something had changed. The engineers who had once looked at Venus with scientific curiosity now looked at it with something else, something darker, a quiet unease that none of them could name. The ghostly silhouettes in the clouds, the strange sounds in the radio data, the unexplained energy spikes. None of it proved anything, but all of it whispered. The program needed answers, not more landers, not more photographs of orange skies and dark rocks. Something deeper, something that could see through the clouds, through the haze, through the illusions, something that could map the entire surface of Venus, hidden for billions of years beneath the thick, poisonous blanket of atmosphere. They called it radar. Venera 15 and Venera 16 launched in June 1983. They were twins, identical spacecraft, each carrying a powerful radar system that could pierce the Venusian clouds and reveal what lay beneath. No landers this time, no risky descents into hell, just orbiters circling the planet from pole to pole, painting a picture of the surface with invisible waves. For 8 months, the twin probes scanned Venus. They mapped the northern hemisphere in stunning detail. They revealed mountains, valleys, craters, and vast plains of volcanic rock. They discovered something that no one expected, a planet covered in volcanoes, thousands of them, some small, some enormous, some dormant, some, perhaps, still active. But then, the radar found something else. Something that made the scientists stop. In the northern highlands, near a region they later named Maxwell Montes, the radar detected a strange formation, not a volcano, not a crater, not a tectonic fault. Something regular, something with symmetry, a series of concentric rings stretching across nearly 100 kilometers, like a target, like a bullseye, like something that should not exist on a planet supposedly shaped only by random geological forces. The lead scientist, a man named Alexander, stared at the radar images for hours. He called his colleagues into the room. "What is this?" he asked. No one could answer. One young geologist suggested it might be a collapsed volcanic caldera. Another proposed a meteor impact with unusual rebound features. But neither explanation fit perfectly. The rings were too perfect, too circular, too deliberate.
Alexander ordered a second scan. The radar passed over the same region 3 weeks later. The formation was still there, still perfect, still unexplained. And then something happened that had never happened before. The radar data from Venera 15 showed a brief, intense burst of interference, a signal that was not noise, not solar radiation, not instrument error, a signal that pulsed exactly 5 times in a regular pattern and then vanished. The engineers checked every system. Nothing was malfunctioning. The signal had come from outside the spacecraft, from Venus itself. They recorded it. Of course they recorded it. They were scientists. They recorded everything. But when they analyzed the signal, they found nothing. No hidden message, no mathematical pattern, just 5 pulses, evenly spaced, as regular as a heartbeat, as if something beneath the clouds was listening. Alexander locked the recording in a safe. He told his team to focus on the geological data. "We are here to map the surface," he said, "not to chase ghosts." But even as he spoke, he felt a cold knot form in his stomach. He had seen the silhouettes images from Venera 9 and 10. He had read the classified reports. He had heard the rumors about the plasma detector data from Venera 13. And now this, a signal from the clouds, a signal that should not exist. He never spoke of it publicly, but in his private journal, discovered after his death, he wrote one line: "Venus is not a planet, it is a question." By 1984, the Venera program was dying. The Soviet Union was struggling. The economy was collapsing. The new leadership had no interest in Venus. They wanted space stations. They wanted Mars. They wanted glory. Venus was a relic, a success story from a previous era. And success in the Soviet system was never enough. The engineers fought to keep the program alive. They proposed new missions, Venera 17 and 18, advanced landers that could survive for days, not minutes, balloons that could float through the clouds, carried by the Venusian winds, even a sample return mission to bring a piece of Venus back to Earth. But the money never came. The approvals never arrived. One by one, the proposals were rejected. One by one, the engineers retired, or died, or simply gave up. The last Venera mission was not a Venera at all. It was a twin mission, Vega 1 and Vega 2, launched in December 1984. The name Vega was a contraction of 2 Russian words, Venus and Halley. The probes would fly by Venus, drop landers and balloons into the atmosphere, and then continue to Halley's Comet, a grand tour, a final, beautiful, desperate attempt to squeeze one last discovery from the dying program. On June 11, 1985, the Vega 2 lander descended through the Venusian atmosphere. It was the most sophisticated lander ever built. It carried instruments to measure the composition of the clouds, the speed of the winds, the chemistry of the surface. And it carried cameras. Not color cameras this time, too expensive, too heavy. Just simple black and white cameras to take one last look at the surface. The lander touched down in a region called Aphrodite Terra, near the equator. For 56 minutes it transmitted data. The temperature was 465 degrees Celsius. The pressure was 91 atmospheres. The wind speed was less than 1 meter per second, a gentle breeze by Venusian standards. And the images showed a landscape of flat, fractured rocks covered with a thin layer of dust. No silhouettes this time, no shadows, just rocks, just silence. But the balloons were different. 2 balloons, one from Vega 1 and one from Vega 2, drifted through the Venusian clouds at an altitude of 54 kilometers. The temperature there was only 25 degrees Celsius, warm but survivable. The pressure was about half of Earth's sea level pressure, almost comfortable. The balloons floated for nearly 2 days, carried by the high-speed winds of the Venusian atmosphere. They rose and fell with the thermal currents. They measured temperature, pressure, density, and cloud composition. And they listened. The microphones on the balloons recorded the sound of the Venusian wind,
a low, moaning hum, like a distant choir, like the breathing of a sleeping giant. The engineers played the recording over and over. Some said it sounded like wind passing through mountains. Others heard something else, a rhythm, a pattern, as if the wind itself was singing. One of the acoustic engineers, a man named Dmitri, isolated a section of the recording and amplified it. For 10 seconds, beneath the moan of the wind, there was something else, a faint, high-pitched sound, like a whistle, like a signal, like something calling out from the clouds. Dmitri never published his findings. He told his wife that he had heard something he could not explain, something that made the hair on his arms stand up, something that made him feel watched. The Vega balloons fell silent on June 13, 1985. Their batteries died, their transmitters stopped. They drifted on, ghost ships in an alien sky, carried by winds that never stop, over a landscape that no human will ever see. Somewhere in the clouds of Venus, right now, as you listen to these words, those balloons may still be there, not functioning, not transmitting, just drifting, silent witnesses to a world that does not welcome visitors. The Venera program is over, but the mystery remains. Somewhere in the clouds of Venus, a ghostly silhouette may still drift, a shape without a name, a watcher without eyes, a whisper from a world that does not welcome visitors. Or maybe not. Maybe it's just a planet, just rocks and wind and acid and heat. Maybe the silhouettes were tricks of light. Maybe the signals were instrument errors. Maybe the shapes on the radar were natural formations. Maybe the engineers were tired and frightened and prone to seeing things that were not there. But here's a question for you, listener. A question that the engineers asked themselves over and over in the dark hours before dawn. If there's nothing on Venus, why has no one gone back? The Venera program is over, but the mystery remains. Somewhere in the clouds of Venus, a ghostly silhouette may still drift, a shape without a name, a watcher without eyes, a whisper from a world that does not welcome visitors. Or maybe not. Maybe it's just a planet, just rocks and wind and acid and heat. Maybe the silhouettes were tricks